Hello everyone, my name is Marisol Olguin. I am from Team 14 and we are Bears Outdoor. My team members are Marla, Kevin, and Alexander, and I am here to explain how Team 14 used data analysis on a real-world example. Who are we? As a reminder, Bears Outdoor is a company that gives customers an option to rent or buy outdoor gear. We specialize in providing non-engine outdoor equipment such as kayaks, canoes, bikes, and fishing rods. Here is our data from project number 1, where we collected relevant data, did all the steps required, and were left with 4 options. Out of those 4 options, we decided to choose 3. Our economy is changing. There is a prediction of a recession soon. As a business, we must be prepared. Since this can affect the demand, we must have the correct amount of inventory for both high and low demands, while meeting, of course, our customer expectations. As you can see on the screen, this is our payoff table. On this side are the bikes, which are decision number 1, 2, and 3. Decision number 1 is the co-op cycles. Decision number 2 is Frame Minnesota, and decision number 3 is trail number 5. On this side, we have the state of natures. For state of nature number 1, it's the number of bikes rented or sold per week with a high demand. And for state of nature number 2 is the number of bikes rented or sold per week with a low demand. So for decision number 1, which is the co-op cycles, if there's a high demand, we are able to rent or sell 9 bikes. If there's a low demand, we are able to rent or sell 8 bikes. After we made this table, we used a decision analysis to determine the recommended decision alternatives. First, we used 3 approaches to decision making without probability. As you can see here in blue, we started with the optimistic approach. The optimistic approach is a decision maker who is really optimistic and is searching for the highest profit. So as you can see here, we have the decisions to the left and the state of natures to the right. If we are looking for the highest profit, we are going to go to the state of nature number 1 and 2, and we're going to go down the list. As you can see here, we have 9, 5, and 13 for state of nature number 1. For state of nature number 2, we have 8, 10, and 4. Out of those 6 numbers, which is the highest? Is 9 the highest? Of course not. We have a 13. So for the optimistic approach, we are going to choose decision number 3, which is trail number 5, because it has a payoff of 13. So if we were to choose the optimistic approach, we would be choosing decision number 3. Second, we are using the conservative approach. The decision maker is a tad bit more aware of the risk, so they want to know which bike to choose in case the worst scenario happens. So if the worst scenario is to happen, they want to know which one is the best. So for us to do that, we use this table to find the minimum. So as you can see here, we have the decisions and the state of natures. Right here, we have a 9 and an 8. Out of those 2, which is the minimum? Of course, an 8. So that's why I went ahead and deleted the 9 and left the 8. For decision number 2, it was 5, and for decision number 3, it was 4. From this table, I went ahead and just did it a little bit smaller so everyone can see that the minimums are right here. So for minimums, we have decision number 1 is an 8, decision number 2 is a 5, and decision number 3 is a 4. So if we were to choose the maximum of the minimums, which one would be the highest? Number 8. So for number 8, that is decision number 1. So if we were to choose conservative approach, we would choose the co-op cycles. Lastly, we did the mini max regret approach, which is the minimums of the max regret. So as you can see here, we have the original data, so we use this table to make a regret table. For the regret table in decision number 1, we have a 4 and a 2. And for decision number 2, we have an 8 and a 0. For decision number 3, we have a 0 and a 6. So if we were to choose the max regrets, we have 4, 8, and 6. So what is the minimum of the max regrets? That is number 4. So if we were to choose approach number 3, which is the mini max regret, we would choose number 1. So that is the co-op cycles. Here I just added the recommendations. So for the optimistic, we would choose D3, state of nature number 1, which is trail number 5, and it has the largest overall payoff. For conservatives, we would choose D1, which is the co-op cycles, and it's the maximum of the minimum values. And for the mini-max regret approach, we would choose D1, which is the co-op cycles, and that is because it's the minimum of the maximum regrets. Next, we made a decision tree where we assume the probabilities. So for the decision tree, we have D1, D2, and D3 right here with state of nature 1 and 2 for each of those decisions and the probability of 0.600 for a high and the probability of 0.400 for a low. As you can see, we have a decision number 1, which has a chance of 8.60. Decision number 2 has a chance of 7.00, and decision number 3 has a chance of 9.40. I also added the expected values right here so everyone can see it. So we have an expected value of 8.6, like I said, for the first one, an expected value of 7 for the second one, and an expected value of 9.4 for the third one. So if we were to choose the best one according to the decision tree, we would choose decision number 3, which is the trail number 5. After we got the decision tree made, we went ahead and made a decision-making methods chart, which we got the expected values from the decision tree. So as you can see here for decision number 3, we got a 9.4 for the expected value, which we got from right here, which is a 9.40. So for the optimal decision strategy, it would be best to choose D3 for the expected value method. The expected value with the perfect information would be 9.4. As you can see, we labeled it right there. And then the expected value with the perfect information would be 11.8 as we labeled. The expected value perfect information would be 11.8 through 9.4, which is the average cost of 2.4 bikes. On average, we would be able to sell or rent 2 more bikes per week. The final decision will depend on the decision maker's opinion on businesses. Moving forward, we went to the sensitivity graph. So for our sensitivity analysis, we have our original chart right here. We went ahead and inserted this formula, which the formula equals P times payoff plus 1 minus P times payoff. And as you can see here, we have decision 1, 2, and 3, and then we have the formula right there. So you can see where we inserted the 9 and the 8, so it's 9P plus parentheses 8, 1 minus P. We had a probability of 0 through 1 with every decision made. Right here is where we solve for every decision algebraically. Based on these intersection points, we can give a recommendation to our decision makers of which decision to choose if they know the probability would change at that point. For example, if the probability for a high demand would be less than 0.6, we would go with this purple line right here, which is the trail number 5. That is decision number 3. So the frame Minnesota is a preferred choice for P equals 0 and P equals 0.33. The co-op cycle is a preferred choice for P equals 0.33 and P equals 0.5. The trail number 5 is a preferred choice for P equals 0.5 and P equals 1. Our decision maker has both the risk and the sensitivity analysis, so ultimately the final decision depends on the available information and the decision maker's choice.